Oh,
Hi
guys,
guys,
Mr. Bennett here.
Just
Today we're going
to
to look at a thing called an impulse force.
We've already done a lesson on
Now we know force is equal to mass times
did.
acceleration,
So
which is Newton's
remember,
second
momentum
law.
is.
Now if we look at what acceleration is,
equal
now
to
acceleration
the mass times
is
by the
the
velocity.
change in the
So
velocity
the units that you can
time.
use, the
Isn't
shortcut
it?
units are things
So
called
therefore,
second
if we have mass times
Or,
change in velocity,
if you want to,
then that
what
will
you
give us
can
our
do is
change
you
in
say
momentum.
mass is
And
measured
that will
in
be all over time.
kilograms.
So the impulse force
Velocity
is
is measured in
defined
meters
as
per
the
second.
change in
And so
momentum
therefore
over
you
time.
can say that is
Now,
the units for
That really
for
indicates, obviously, it's
Um,
really important
we did
to
look at two
understand,
examples in class, so if we
like,
just have a quick look at those.
if something
So we had
collides
a
with
truck and
something,
a car coming through,
it's going to be that interaction
and
that they
we had
have
the
together.
before and the after
Right? So we're going to
situation.
do a very simple
So if
example
you look at
here
over
today
here, we had
to work out the force that
the
a
first
ball
step
can
was to
exert
work
on
out
the
the
wall
velocity of the car to be
in an
in meters per second.
Right? Now,
And
I'm
also
giving you a
the truck to
scenario.
be
Here's a
in
brick
there.
wall. We've got a
And what we
big
said
basketball,
was the
quite a heavy
initial
basketball
momentum of
there,
the system
and the basketball is
equal
going to be
to
impacting
the momentum of
for,
the car,
let's say,
and then
0.1
the
of a
momentum of
second.
the truck. So
Right,
it
so
worked out to
tenth of a
be
second is how long
about
the interaction is going to
22,000
be.
sec newtons for
And
the
the ball
car,
actually hits the
and
wall
about
and then being
78,000
bounds off the
sec
wall.
newtons for the
Right,
truck.
so now
So
we know the change
total
in
initial
momentum
of these two things. Now,
as in
because they're
anything,
going in different directions,
and change of velocity is
when
the
you
final
add the two
velocity
vectors
takes initial
together,
velocity.
I'm going
So change in
tail,
momentum is going to
tail,
be
head.
the
Then the
final
initial
velocity
momentum was
take the initial velocity.
the addition of both
Right,
of those. So that
if
gives
we're
you
throwing
vector
a
of
basketball
that
at a wall,
55,000
we'd say this vector
going
here
to
is
the
the
left.
initial velocity.
Right?
We'd say
And
this
then we
vector
use
over
the
here
concept
is
of
the
momentum
final
to say,
velocity.
well, after the collision, both the truck and the car
Now,
are going to have.
we're going to say
combined
this is
mass
an
of
elastic collision. So an
4,800
elastic
kilograms.
collision means that there's no energy
Right.
loss.
And so,
So
therefore,
if we work
we
out the
know that
momentum
the
of
initial
the actual
momentum
basketball,
of the
now
system
200
should be equal to the
grams
final
is
momentum of the system.
0.2
So
of a
this
kilogram
answer we got for
times
the first
that
part
by
over here,
15 meters per second.
basically,
So obviously,
should
if
give
I
you,
would times that, that would actually work out to be
that value.
3 sec.
And then we know that the mass
Right.
over here
So we
is equal
know
to
that
4,800.
the
It's
thing
got
at
3
3
sec
sec
newtons
newtons going that way
here
and
was the
it's 3
velocity
sec newtons
of
going
the
that
car
way.
and the
Now,
truck
what this means here is
So
my
if you
change in
divide
momentum
that value
is equal
by
to a
that
vector
value,
addition. So it's my
right, then
final
you'll get a velocity
momentum
of 11.57
going that way
meters per second, or 41.65
plus we'll
kilometers
take
per
my
hour.
initial momentum. Now,
So coming to the
my
next
initial
bit,
momentum
you can also
goes
do
in
this
that direction
mathematically.
there. So that
The way we
there
do
is
this
supposed
mathematically
to
is
be
because the truck
minus
is
my
going
initial
to the
mo-
left
minus my
as the
initial
speed of
momentum
negative
goes
90.
the same
Right,
length,
so
but
when
in
you
the
do
opposite
the
direction
mathematics,
as to
that
the
will give you a
original
value.
And
So
then you did the same
therefore,
thing before.
this is
We
going
also
to
did
be
a very
quick example of a bomb.
This whole
Exploding.
vector here, you
We
imagine
said
that
that
being
before
straight
the
line.
bomb
You have to
obviously
use your
takes off,
imagination here.
because it's stationary.
That is the change in my
explode.
momentum.
It's got
So
a
zero
therefore,
momentum. My
okay,
change in my
nothing's zero
momentum in this
velocity,
particular
zero momentum.
case is actually
And
going
then
to
what
be
we
equal
said was we had
to
these
3
particles
sec
going
newtons
off at a different direction.
plus 3
Right, so
sec
particle number
newtons.
1,
So that's going to give me an answer
3,
of 6
I gave the
sec
information about the
newtons.
momentum for that and for
Now,
particle
we
number
know
2,
from Newton's second law
so we could work that out.
obviously
So
that
momentum,
change in
particle
momentum
number 1 goes up this
um,
direction here at 2,000
of
sec
6 sec
newtons,
newtons. Now,
goes this
obviously
way here
reaction,
at
reaction,
1,500 sec
right,
newtons.
so when we
know
think
the
about
mass
the
of particle
force
number
there,
3, but we
right,
don't know
so
its
the
velocity.
force
But if we use
is
Pythagoras
equal
and
to
the concept of
6
conservation
sec
of
newtons.
newtons,
So
we
the
know
force
that
is
the
equal
initial
to the change in
momentum has to be
momentum
to the final
over the
momentum,
time period.
which has to
We
be
know
equal to 0
our
in this particular
momentum
case.
is equal to 6
So
sec
therefore,
newtons. That's our
if
impulse
we use
force.
Pythagoras, because we know those
all
go
over a
at
time
right
period of
angles, we could work
0.1.
out what the momentum of
Okay,
particle
so
number
therefore
3
that
was,
means
and
that
worked
this
out
is
to be
actually going to have
2,500 sec newtons.
60 newtons.
Then if we
worth of
know
force
the velocity
acting on the wall.
or the mass
So
of
you
it,
throw a basketball
which is
at a wall, it's
divide
got to
the
have
momentum
it will
by
have
the mass, and we
60
get
sec
the
newtons worth
volume
of force,
of
or
velocity
60
of
newtons
the-
worth of force
of
on the wall.
the actual third.
Now, if that wall can't
fraction
push
of the
back
bulk
with
to be
60 newtons
5,000
worth
meters
of
per second.
force,
Right,
what
today
will
we just want to
happen?
go through a
well,
couple
we
of
can't push
examples
back with
for you.
60
So
newtons worth of
if
force.
we did this
You
example
actually
over
knock the
here,
wall over. Alright, so
right,
have you
so we've
ever
got
seen
this
those
example
videos
here,
where
so
you
we've
have
got
a big
truck
wrecking
which
ball?
is 4,000, we've got
Right,
a
big
car.
wrecking ball
Now,
has a
the
massive,
truck's stationary. So what
massive
we've got here
chain on a
is
big
car going in
pendulum,
and hitting the stationary truck.
and
So
you've got a massive
if
ball
this
on
has
the
got
end.
zero
What
velocity,
happens is
we
when
know
that ball hits
truck
the wall,
has
it hits the wall with more
zero
force
momentum.
than the wall can push back with. So
and
that means
the
that
momentum
the wall will
of
crumble
the
over.
car and the truck
Right,
combined
so
initially will be
If
only
you hit
about the
something with
car.
more force than
So
it can actually
the
push back with,
car,
then
that's going to
that
be simply
particular wall
mass
will fall over.
800
Right, so you get the
Times
idea
by
of the impulse. So just running through that very quickly again. Very simple concept now. This is really a part of physics that you need to develop, which is you need to be able to use one formula to develop another formula. We call that a derivation. Okay, so we've got force impulse, which is equal mass times acceleration. We know accelerations are change in velocity over time. So therefore, mass times the change in velocity is in fact the change of momentum over time.
So in other words,
So
my
this
initial
is the
momentum,
other key concept. Change in momentum means final momentum, take initial momentum, right? So initial momentum is a vector going in that direction there to the left. So minus initial momentum will be a vector that goes in
Now
that
what we
direction
know
there,
is by
minus
conservation,
pi.
I have to state
Goes in the opposite direction of the same length. Again, when we're adding vectors, we go tail
of
head,
momentum,
go from tail head, and so therefore we have a vector that goes in
Pi
that direction away from the wall.
has to be equal
Now,
to
in year 12, we'll extend that
Now,
concept
obviously,
to
in
looking
reality,
at it
it's
comes in
not,
at an angle.
because in
But this
collisions we
year,
have things,
if we do
energy
anything
losses
in
with
a
things
test
like
situation,
sound and
we'll be considering
heat
those being straight onto the
crumpling
wall.
and all that sort of
Alright?
stuff. Alright, so,
And so therefore,
but in
to work out what the
ideal
impulse
world,
force
we might
is, you
deal
need to
with
know
in
how long the
physics.
ball's going to
Right,
interact
we
with the
know
ball.
that these two things
You need to know
are
what
going
the
to
change
be
in momentum is,
So
and we work that out
therefore,
to be 6 sec
again
newtons.
goes back to
And
the
therefore,
P
the interaction
final
length for 0.1 of a second
is going
so
to be equal
therefore
to the
that works out to be
mass of the
force
truck
of
and
60
car
newtons. I hope you find that pretty easy. It is actually,
times by
I
the
think, quite an
velocity
easy concept
of the
once you
truck
get
and
it.
the car.
Alright,
Remember
so
we use these
I
subscripts to
think
help
you've
us
got a few of
understand
those
what we're doing.
questions have a go in
So
one
now I
of the
can put all the
tutorials.
things
So
that I
good
do
luck
know.
with them.
We know that's
And again,
2
make
to
sure you catch up with me if you need some help.
22,204. Alright, and then we know that this over here is going to be 4,800, and that's times by the velocity of the truck plus the car. So therefore, the velocity of the truck plus the car is going to be equal to 22,224 divided by 4,800. Now on my calculator I've already got that answer, so all I have to do is now go divided by 4,800, and that will give me my answer of 4.63, and if I times that by 3.6, that will tell me kilometres per hour. Okay, so if I go back to that, so that's 4.63 metres per second, which is approximately equal to 16 kilometres per hour. Okay, so we go through that process. Now, the one that you'll get in your test, and I'm expecting you to do, will be something like that, where you've got something going in the same direction. Now, example number 2 today is looking at a car. 2 cars. We've got a blue car and a red car, and they've got different masses and they've got different speeds. Now, I've already done the calculation for changing that to metres per second, because you need to be working in SI units. Right, so I think if we think of the vectors, now you don't have to do it vectorially, I'm going to do it mathematically today for you. So I'm going to say here, and this is probably good setting out, the initial momentum is equal to the momentum of the red car plus the momentum of the blue car, isn't it? Alright, so if we think about that, the momentum of the red car is equal to the mass, which is 800, times by 27.78, plus the blue car, which is going to be 1200, times by 25. So that's what I can do on my calculator. So it's going to be 800 times by 27.78 plus 1200 times by 25, and that will give me my initial momentum, which is 52,224. 52,224 sec newtons. Okay, what do we know about our situation over here? Well, we know that afterwards our PI has to be equal to our P final.
So what are these cars doing? They're going to have a rear end collision, and then they're going to go off at a combined speed. Okay, so we know that our P final is going to be the mass of the red plus the blue times by the velocity of the red plus the blue. Right, so in this particular case we know that this is 52,224. We know this is going to be 2,000, and that's our velocity of the red plus the blue. So therefore we're going to simply divide that by that. So if I go back to my calculator, divide that by 2,000, and that will give me a speed of 26.11. So velocity of red plus blue is equal to 26.11 meters per second. That's what it is. And if I want to times that by 3.6 equals 94 kilometers per hour. So if you were involved in that collision, it'd be quite a fast collision, wouldn't it? So that would represent, you know, a rear end collision. I can't quite remember the last bit. It's straight on 94 kilometers per hour. Okay, so that's kilometers per hour there. So these cars are moving, so therefore the collision means, you know, you're going to be continuing to move off at quite a speed. Because they're going in the same direction, it probably wouldn't be such a dangerous collision as if it was a head-on collision. Now remembering what we're doing here, if we've got a car going to the right, what we say is we have a positive velocity. If we have a car going that direction there, we have a negative velocity, if we want to do it mathematically. In this case, both of them are moving to the right. Let's do another example. This is another example of something that you may recognise. If you've all played 8-ball or pool, you have this situation where you fire the white ball at the red ball, and then what might happen is the red ball might go off at a speed and the white ball might be stationary, or you can even do things like put spin on the ball and it comes backwards. But we're saying there's no spin here, and what you've done is you hit the red ball and the white ball goes off at a certain speed and the red ball goes off at a certain speed. Alright, so we want to find, in this question here, we want to find what speed does the white ball go off at. Obviously it's a straight collision there. So again, the red ball is stationary, so it's got no momentum. The momentum of this system here, right, initial momentum is going to be the momentum of the white ball plus the momentum of the red ball, but we know this is in fact equal to 0. So really it's just the momentum of the white ball. So that's simply going to be mass. Actually, I don't need to write that in. We know what momentum is. So what's the mass of the red ball, of the white ball? Well, it's got 40 grams. Now 40 grams is equal to, have to divide that by 1,000 to get that to kilograms. So that's going to be 0.04, isn't it? Times that by 1,000. Yeah. So that's going to be 0.04 kilograms. So therefore my momentum of here is going to be 0.04 times by my velocity, which is going to be 10 meters per second. So that's going to mean that my initial momentum is going to be 0.4 sec newtons. Okay, and it's to the right. Now remember, this is a vector quantity, so therefore I should give a direction, and I didn't do that with the previous examples, which is wrong. I should have done that. Now, we need to say by conservation, you need to say that it's part of the question of momentum. I hope you can write better than I can. Pi is equal to P final. So therefore, we know that our final momentum, P final, has to be equal to 0.4 sec newtons. Now,
Our final momentum in this particular case is equal to the momentum of the white ball plus the momentum of the red ball. Now, both these balls have got the same mass, so therefore what I'm going to do in this case is just work that out. So we know this is 0.4 sec newtons. We know this is 0.04 times by the velocity of the white ball, and that's going to be 0.404 times by the velocity of the red ball, which is 8, isn't it? So 0.4 is equal to 0.04 W. Now that times by 0.04 is going to give me 0.32. Right, so therefore I'm going to bring that across, so that's going to give me 0.4 take away 0.32 is going to be equal to 0.04 VW, and so therefore that's going to give me 0.08, and then I have to divide that by 0.04, and that will give me my velocity. So when I divide that by 0.04, that's going to give me a value of 2. So therefore, the velocity of my white ball has to be equal to 2 meters per second. And I was suspecting I was going to get that result anyway, because the only thing that's really changing here is, in fact, the velocity. So if it goes from 10 meters per second to 8, then I was thinking that this thing over here had to be 2 meters per second for conservation of momentum. In this particular case, we would say that the momentum is directly proportional to the velocity, because the mass is actually not changing in this particular case. And that's a really important language thing that you need to start working with here. Right, the mass is constant, so we would say that the momentum is directly proportional to the velocity. Now, in terms of what I'm expecting you to do, I'm expecting you to do any of these things here with objects moving in a straight line. So it could be stationary and one moving, they could be both moving in opposite directions to each other, or they could be moving in the same direction as each other. But, you know, going through, I've done, obviously there's 4 examples we've got there to look at. So the key steps are for doing these is working out the initial momentum, which is the addition of the 2 objects. The second step is to make sure that you're using the conservation law of momentum. And the third step is to actually find the unknown by using the formula there. Have a go at these questions. If you have some trouble, make sure you catch up with me in class.